Hello friends, welcome to Igniter Max. At this video, we are going to ignite the concept of the quadrant. From the quadrant, the trigonometric functions contains the positive and negative value. How did it came? Related to complete concept we are going to discuss at this video. How the quadrant is mentioned, like the first quadrant contains the all trigonometric function as positive. At the second quadrant, we can see only a sine cosec should be positive and rest all the terms should be negative. And at the third quadrant, we can see only tan and cot theta should be positive, rest all the trigonometric function will be negative. And at last, the fourth quadrant, in which only cos and sec will be positive and rest all the things will be negative. How does it happen and why it happen? How? Regarding that the question will occur. So now we are going to clear the concept at this video. So stay till the end so the concept will be clear. So let's find the trigonometric functions in different quadrants. Construct the Cartesian plane, that is the x coordinate and y coordinate, and we will mention the O as a origin and we will construct the ray OB in the first quadrant. Let's bound a circle in such a way that each and every quadrant contains the 1/4 of the circle. Take a point P in which it lies in the first quadrant. First quadrant, the angle lies between 0 to 90 degree, so the theta will be between 0 to 90, but we don't know the actual value of theta, so we will name as a theta only. We are going to construct the point P from the x coordinate. Okay, yes, we have done with it. Now if we observe over here, the right angle triangle occurred. Let's name the radius of the circle as r. Okay, we have already named the point P, in which P contains as an order pair of x and y term. Why x and y term? Because the P contains of the x coordinate, even over here the y coordinate. For example, if the x value is touching over here, it's 2. For example, I'm saying, so the x value will be 2, and over here the y part is there, right? Over here we can see the y part. So if the example I'm going to give the 3, y value will be 3. This is what the ordered pair say. The x term contains from the x coordinate, so the value over here will be x. Yes, absolutely. Now this y contains of the y coordinate, so over here the line form, the value will be y. This is how we are going to construct from the Cartesian plane some of the basic formulas from the trigonometric chapter, that is sine theta is equal to opposite upon hypotenuse, related to the trigonometric ratios, trigonometric identities. We have already gone through it. If not, then we will get at the description link. Okay, so at this moment we are going to use it. Okay, now the sine theta says that is equal to opposite upon hypotenuse. Now the right angle acute triangle is mentioned over here. Okay, now we need to mention upon opposite upon hypotenuse. Now the theta is over O and right angle over here, so opposite side of the right angle will be hypotenuse, so the hypotenuse nothing but r over here, and the theta is over here, opposite side will be y and the adjacent will be x. Okay, now let's start with the trigonometric ratio. Sine theta is equal to opposite upon hypotenuse, so the theta is over here, opposite side will be y, ratio by hypotenuse, so r. So sine theta will be named as a y by r. Now next cos theta. Theta is over here, adjacent side divided by hypotenuse, the cos theta says. So adjacent will be x and the hypotenuse r, so x upon r. Now tan theta is equal to sine theta by cos theta. The one formula we have already derived it. Okay, and the other formula is opposite upon adjacent. So the opposite side will be y and the adjacent is x. So y by x. Now if the free trigonometric function we have done with it, then the 50% work is over, because rest 3 will come automatically. Just take the reciprocal of each and everything. For cosec theta is equal to 1 by sine theta, sec theta is equal to 1 by cos theta, cot theta is equal to 1 by tan theta. Doing this, we have named the r as the radius of the circle. Now we are going to take the r value as 1. It's nothing but the unit circle. Unit circle is named as r is equal to 1, in which it contains the radius as 1. So it's called as a unit circle. Now let's take r is equal to 1. This is the value of it. So after taking r is equal to 1, at the trigonometric ratio we have already derived it. Just put the value of the r. Wherever the r is there, we need to put it as 1. Okay, like sine theta is y by r. So we need to write as y by 1. So it's nothing but y. The same thing is procedure is applied for each and every trigonometric function. We can even watch carefully. Definition we got as cos theta is equal to x by r. We can see over here cos theta is equal to x by r. Okay, and sin theta is equal to y by r. So x value I keep it over here and r I take it in the LHS. So it is in the division form, so it will come in the multiplication form. So x is equal to r cos theta, and over here also same, y is equal to r sin theta. So in place of xy, that is we have mentioned over here, even we can write as r cos theta and r sin theta. Is one of the proof that y p of xy is equal to p of r cos theta and r sin theta. It's one of the proof of it. Describe each and every quadrant specifically. Like for one by one we are going to do it. That is for the first quadrant over here, for the second, for the third quadrant, and for the fourth quadrant. So we are going to hide each and every quadrant. Let's do for the first quadrant, and one by one we are going to do it. Okay, and afterwards we will come to know related to it. I have distinguished in the 4 parts like first quadrant, second quadrant, third quadrant, and fourth quadrant. We have distinguished it. Okay, now let's take one by one. At the first quadrant, we have described the Cartesian plane, that is x coordinate and y coordinate over here. Now the theta, that is the angle, lies between 0 to 90 degree. Why? Because it lies in the first quadrant. So I have construct the line OB over here, and the point P of xy, as we have seen earlier also. Okay, the x contains in the x coordinate, okay, over here, and y contains of y coordinate over here. Okay, x coordinate and y coordinate, it contains of, that's why P of xy. Now first note that we need to note it over here, each and every term contains the positive term. Over here also it contains the positive term. So the x and y will be positive, whatever may be the number, 1, 2, 3, anything, but it will contain in the positive. So all the trigonometric function contains the positive term, because and earlier we have seen, let's take r is equal to 1, right? So in that we have done the sin theta is equal to y, cos theta is equal to x, and tan theta is equal to y by x. So the same variable we have took over here. So each and every trigonometric function contains the positive term. This is what we have done earlier. By relating it, we are specifying the sign of the trigonometric function. So at last, at the first quadrant, each and every trigonometric functions contains the positive term. For example, sin theta, cos theta, tan theta, whatever, cosec, sec, cot. The 6 trigonometric function contains the positive term. With the help of the trigonometric ratios and with the help of the unit circle, we have derived the first quadrant. The same procedure is applied for the second quadrant also. We are going to do it. The second quadrant is also displayed. Okay, now second quadrant is over here, in which it lies between 90 to 180 degree. Okay, so in that I have took a part over here. Okay, it will be so easy in distinguishing, that's why I have distributed in this way. Now over here also the Cartesian plane is occurred like x coordinate and y coordinate, but the theta lies between 0 degree to 180. Okay, it will lie between that 0 to 180, will lie between maybe 120, 130, anything, but it will be greater than 90. And we have constructed the line OB, in which we have mentioned the point P of xy. Now the thing that we need to note it, whether the x is positive or negative. This is an important thing that we need to note it. Like over here, the term contains the negative term, -1, -2, -3, in that way it will go to the term. And over here at y coordinate, it will contains the positive term, as we can see it now. So P of xy, so the x term that is over here contains the negative term, so it may be x variable, minus 1, minus 2, it will be n types of variable, but it will contain the negative term. This is what the possibility. Over here y, it may be 1, 2, 3, but it will contain the positive variable. So over here minus, over here positive. Okay, so wherever by the trigonometric ratio, wherever we will get the x term, like sine theta is equal to y, so y is positive, so y term will be positive, that is sine theta will be positive. Cos theta, you can see, in which cos theta says that x by 1, so x, okay, x is negative over here, x is negative over here, so the cos theta will be negative. Tan theta is equal to y by x, so y by minus x, so again it will be negative form. So the only way is sine theta will be positive, so the ratio of the sine theta is 1 by cosec theta. Even the sine and cosec will act as the same, it will only act in the positive way, rest all the terms will act in the negative term. This is how it's distributed it. For the third quadrant, okay, at the third quadrant we have described the Cartesian plane over here, that is the x coordinate and y coordinate. Now the third quadrant, the angle lies between 180 to 270, so the theta is from over here to here. Yes, now we have constructed the line OB as a point as P of xy. Now the thing that we need to note it, at x coordinate the term will be as negative, that is minus 1, minus 2, minus 3, okay, and over here also minus 1, minus 2, minus 3, like this it will going on. So the P of xy will be written as P of minus x minus y. The x and y term contains the negative term. Now we will take with the relation with the trigonometric ratios, that is sine theta is equal to y is negative, so the sine theta will act as a negative in the third quadrant. Second, cos theta is equal to x is also negative, so the cos theta will be also act as a negative term. Now tan theta is equal to y by x is nothing but minus y and over here minus x, okay, in which in place of y by x even we can take the term, that is minus 1 divided by minus 2, anything we can take it also, but for the reference we are doing it, but while solving the sums we will get the clear concept. Over here minus will be as a positive, so the answer will be y by x. It came in the positive term, so add the trigonometric ratios in the third quadrant, the tan theta and cot theta will act as a positive term, rest all the terms will act as a negative term. Now let's come to the fourth quadrant. Yes, the fourth quadrant is also displayed over here, in which the fourth quadrant the angle lies between 270 to 360 degree, okay, so the angle theta is formed over here. We have constructed the line OB with point P of xy. Now let's describe about the sign. This is the x coordinate, right, so it will be positive. Over here it will contain the negative, so the x term will be positive and y term will be negative term. And again we are going to apply the trigonometric ratios as we have seen, that is sine theta is equal to y is negative, so the sine theta will act as a negative term at the fourth quadrant. And cos theta is equal to x is positive, so the cos theta will act as a positive term, but the ratio of the cos theta is sec theta is equal to 1 by cos theta, so even the sec theta will act as a positive term at the fourth quadrant. Now even we can check for the tan theta also, so tan theta is equal to y by x, so y is in the minus term, minus by x it's nothing but negative, so even the tan theta will be also act as a negative term. Okay, this is how we have described it, that is at the first quadrant all the trigonometric functions are positive because the x and y term contains the positive term, that's why. Now at the second quadrant the x term contains the negative term, the x term contains the negative term and y term contains the positive term, so the sine and cosec theta will follow as a positive term and rest all the contains of negative term, that is tan, cot, cos, sec will contains the negative term over here. Okay, over here minus x minus y, so tan and cot theta will act as a positive term and rest all terms will act as a negative term. Over here at the fourth quadrant, okay, fourth quadrant, only cos and sec theta will act as a positive trigonometric function and rest all the function will act as a negative trigonometric function. This is how we have described each and every quadrant. Trigonometric angles. For examples related to the trigonometric functions in which we need to state the sign of the trigonometric function, at which quadrant the trigonometric function act as a positive term and which quadrant the trigonometric function as a negative term, as we have explained. So related to it, we are solving the examples. Let's start with the first example, that is tan 380 degree. First, split it in two parts, tan 380 degree. Okay, we will complete with the 380 degree. First, we need to know that where the 380 degree lies, at which quadrant the 380 degree lies. Okay, now let's describe the quadrant from 0 to 90, first quadrant. Okay, so 380 doesn't comes under it. 90 to 180, the second quadrant. Even the 380 degree doesn't comes under it. Now from 180 to 270, third quadrant. No. 270 to 360, the fourth quadrant. The 380 degree comes in after the 360 degree, that is after completing one complete rotation, that is after completing the fourth quadrant, then the 380 degree comes it off. 380 degree, if we are splitting in such a way, that is 360 degree plus 20 degree, then it will be easy to understand that where the 360 degree lies. We can split in such a way that 90, 180, 270, 360, in which we can understand the concept very easily. For that purpose, we have written over here. Okay, so 360 degree plus 20 degree, then we can understand that after completing one complete rotation, then after 20 degree the 380 degree comes it off. So it is lying in the first quadrant. At the first quadrant, all the trigonometric functions are positive. Now the question is given in tan, so even the tan will be also positive. Question. The second question is given in cot 230 degree. First, we need to know where the 230 degree lies, at which quadrant it lies. Okay, let's start with it. Now 0 to 90, first quadrant. 90 to 180, second quadrant. 180 to 270, third quadrant. Now the 230 comes and between 180 to 270, right? So it is lying in third quadrant, as we have written over here. Over here also we have split in such a way that 180 degree plus 50 degree. Now while knowing where the 180 degree lies, so it will be easy to understand. For that purpose, we have written like over here 360 degree, over here 180 degree, 90 degree. Okay, it will be easy to understand. So 230 degree lies in the third quadrant, yes, but at the third quadrant only tan and cot theta act as a positive term, rest all the terms act as a negative. So cot theta is also positive in the third quadrant. Now the third sum, that is sec 468 degree. Now we need to know that where the 468 degree lies it off. So let's start with the game. 0 to 90 quadrant and 90 to 180 the second quadrant and 180 to 270 the third quadrant, 270 to 360 fourth quadrant. We have completed with one complete rotation, but the angle is given as 468 degree. So it will just move it off like 360 to 450 the other first quadrant. Okay, after completing one complete rotation again. Now still it not came because we came it off 450 degree only, but we need to come it off 468 degree. So it will lie in the second quadrant, that is after completing one complete rotation it lies in the second quadrant, that is 468 degree is equal to 360 degree plus 108 degree. Yes, so here is the explanation about it. So 468 degree lies in the second quadrant, but at the second quadrant only sine and cosec will act as a positive, rest all the trigonometric function will act as a negative. So the sine will be, okay, we need to state the sign, right? So sec 468 degree is negative. We have completed with the proof of the quadrant. While doing this sum, there is no need to mention each and every proof. So that let's discuss some of the tips. Statement is all students take coffee, in which the first word all is mentioned for the first quadrant for all trigonometric functions. Each student, in which the first letter is S. So sine, and the reciprocal of sine is cosec. So for second quadrant, the sine and cosec. And tick, it's T. So tan, and the reciprocal of tan is cot. So it mentioned for the third quadrant. Now at the fourth quadrant, it's coffee. So first letter is C. So the trigonometric function suits for cos, and the reciprocal of cos is sec. Just a tip for understanding it. Even we can take for the other statement also, like all student take commerce. It's up to us, in which we can understand very easily. For that purpose the tip is used. For watching this video. If this ignited max is so helpful, then don't forget to subscribe it.